Today we are doing 8.6. Can someone tell me the objectives of today's lesson?
To solve rational equation.
And
Story problems.
We're going to be doing story problems. So yesterday you guys took a test on how to solve rational equations, right?
Yes.
Can you tell me what a rational equation looked like?
2x over 1 plus 1 over x.
Okay. What? But I'm waiting to hear something. Equals
Another
equals another fraction. So what you're going to have, I'm going to just flip this page really quick. Here's two examples of the kinds of problems that we've been working on. Okay?
Yes.
So why don't we start here? Let's start with problem 3, just to warm us up. Everybody look at problem number 3. How do you solve this? You just took a test on this. Problem 3, it's on the second page in the middle.
You get a common denominator.
What is your common denominator, Brett?
X plus 2x minus 2.
So you're going to multiply this, and this by x plus 2, x minus 2. So this is just a little warm-up. Okay, what do I do now?
You cancel.
Cancel what?
The ones that are in the.
Those two, right?
Yeah.
And
Where
what's
did
left
those come
here?
from?
2x minus 4.
Mm-hmm. Next, what do we do?
Cancel 4x minus 2.
What do you get here?
X squared plus 2x.
Equals, what's this?
X squared minus 4.
X squared minus 4. Good. Next, how are you going to solve this?
Combine them with.
What cancels?
The negative 4. Wait,
The what?
X squared.
These x squareds cancel. What else cancels?
Nothing else really cancels. Negative 4s don't cancel, they're the same thing. It has to be opposite
negative
cancels.
4s. So it's 4x equals 0.
Wait a second. 4x
4x.
minus 4.
This is 4x
Yeah.
It's
So it
4x
equals 0.
minus
equals 0. These cancel.
Yeah.
What's x?
0.
0. 0 is the answer.
Making
0 is
sure
the
it's
answer.
all
Can
that,
we
right?
check this to make sure it works?
Yes, you plug in a 0.
If you put a 0 right here, and a 0 right here, what's 0 plus 2?
2.
2 over 2 is 1, and this is going to go to 0, and 1 equals 1. So it worked.
Ding, ding, ding.
That is the correct answer. Okay, what about this next one? How would you solve this one? What's the fastest, easiest way to solve this one? I'm going to give you a hint. Do you know it now?
Cross multiply.
Yep, cross multiply.
Hey, girl.
When you have two fractions set equal to each other to solve this rational equation, I would cross multiply. What is 1 times x plus 2? What's 5 times 1 minus 2x?
Negative 10x
What's that?
plus 5.
5 minus 10x? Okay, how would you solve this?
Add 10x.
Add 10x, you get 11x here. Subtract 2, you get,
So,
and divide by 11. Questions?
It's off.
Sam, what were you asking?
nope, I'm good.
You good? Everybody's good? Now, can you give me this answer a different way? What other way can you give me 3 11ths?
As a decimal.
As a decimal.
I get you.
So 3 divided by 11 is
0.273.
0.27.
You're purple.
So 2.27.
I like it like this.
Keep it.
Now-
Sure.
I'm going to show you another way that you could solve this problem. You can use a graphing calculator. I'm going to type this equation into my calculator. How are you going to type this in your calculator? Well, if you're using the old calculators, the 83s, how do you type this in your calculator? You're going to go to y equals. Now, I need to do this fraction. This is where it's tricky. So you're going to do a parenthesis, x plus 2, divided by parenthesis 1 minus 2x. Whoops. 2x. Now, I need to bring this 5 to the other side. So I'm going to subtract 5 and hit graph. Okay, I'm going to look at my window for a second. I'm going to zoom to standard. Now, where the graph hits the x-axis right here, that is the solution. How can I figure this answer out right here? You can hit second, calc, 0. And it's between, you want to go real close to this. So I'm going to say -1, enter, and 0.5. Now why I don't want to do 1 is because it's going to get too close to this. I'm not going to guess. Hit enter again, and look at that, there's your answer, 0.2727. And when I did 3 over 11, the answer was 0.27 repeating. Okay? So you can do these on a graphing calculator as well. They get really ugly, but you can do them. All right, now I want you to go back to the front page. Now that we're warmed up, how do you do these rational equation story problems? Well, here is a very good example of this in action. Have you ever rode a bike against the wind?
Yes.
Ridden against the wind? Have you? What, tell me, explain your experience.
It's hard.
Yeah, pedal bike.
Yes, the pedal harder.
If you're going with the wind,
With the wind?
The tailwind is pushing you forward and you go fast.
oh wow, he's using the words.
What did you say?
The tailwind, like when it's pushing with you.
With the wind, you're going faster, right? Against the wind, you're going slower. Do you agree with that? Nick is absolutely correct. With the wind, it's called tailwind. Against the wind is called headwind. we like tailwind, right? When we're pedaling our bikes and the wind is pushing us, and sometimes we don't even have to pedal. You're just moving along, you can let your legs take a rest. This is gonna be R plus W. What is R? R is your speed, your legs working. W is the wind pushing you. Nick? Headwind we don't particularly care for, because why? Why don't we like headwind? Because you have to put more effort into pedaling. You're gonna call this R minus W. It's gonna make you go slower. So either if you wanna continue at the pace that you wanna be, if you gotta get somewhere, you're gonna have to put more effort into pedaling, right? But I need you to understand that faster is gonna be your speed plus the wind speed. Slower, which is called headwind, is your speed minus the wind speed. Remember this, headwind and tailwind. Have you ever gone on a trip on an airplane? And it normally takes like, I think to go to Florida, it's usually like 3.5 hours.
But you got a tailwind. So it's like
And then you get a tailwind and the pilot comes on and says that you're gonna be there like 15 minutes early. That's usually what happens, is there's a tailwind and it's pushing the plane going, it's gonna make it go faster. So the pilot will set the plane at a certain speed, but the wind will push it, make it go faster. And you'll end up at your destination, that's tailwind. If it takes you longer, then it's gonna be R minus W. Okay, so keep that in mind. Now, let's apply this to this story problem. A flight across the United States takes longer when you go east to west than it does west to east. Why? Because of the wind. Okay, so we're gonna assume that the wind is constant, like it's not changing. It's one, we're gonna call the wind speed W. When you're flying west, when you're going to the west coast, where's the west coast? Right here. Here's west. So when we're flying west, we have headwind. It's gonna slow you down. It's gonna slow the airplane speed down. When you're flying eastward, we're gonna go faster. We like tailwind. So it's gonna be R plus W. The time for the entire trip is 7 3/4 hours, so 7.75 hours. The plane speed is 480 miles per hour. So they wanna know what is the wind speed. Everyone cool with that? So, see if this makes sense. The distance going from west to east, the distance does not change, it's 1850. But going west to east, you go faster, so it's 480, that's the plane speed plus the wind speed. Now, I like to use, instead of X, I like to use W for wind speed and R for the speed of the plane. So this would be R plus W, and this would be R minus W. Now I want you to look at this formula. Distance that's a C is equal to rate times time. If I knew, if I had information on the time, how do I solve for time? How do I get this rate out of here?
Divided by the rate.
Divide by rate. So the distance over the rate is equal to the time. So if the distance is 1850 and the rate is 480 plus W or plus X if you want to use it, your time is going to be 1850 over 480 plus X. And same with going east to west, it's going to be 1850 over 480 minus X. Now in the problem, it says the entire time to go from San Francisco to Chicago, Chicago back to San Francisco, the entire trip took 7 hours, 7.75 hours. So this is your problem right here. It is, I'm gonna write it for you. 1850 over 480 plus, if you wanna use X or W, 1850 over 480 minus X. The entire trip took 7.75 hours. This is what we've been working on. How do we solve for X, which is the wind speed? What's your common denominator?
480 minus 6, 480 plus.
Yep. And unfortunately,
They're big numbers.
they're big numbers. So just like we practice these problems with smaller, nice numbers, these ones aren't as nice. But you can't do the hard problems unless you know how to do the easy ones. So that's why we start off small and work our way up to these. So now how would you solve this? What cancels here? This cancels with this. So what you have is 1850 times 480 minus X plus, these cancel. You have 1850 times 480 plus X. And then you have 775. Does anyone know what this is? It's the something of two perfect squares.
The difference of two.
Difference of two perfect squares. So what you could do is do 480 times 480. What's 480 times 480? Anyone know?
50.
It's 230. Now, what would be the game plan now to solve this? What would you do? Distribute, and now you're gonna simplify. Now, I have it right here for you. Here's the work. So you can see these ugly numbers in action here. This problem, that the middle term ends up canceling out, so what you're gonna do eventually is take the square root of both sides. You end up with this number right here, using a calculator. This is more a calculator activity than anything. You're gonna get plus or minus 35. You can't have a negative wind speed, and X represents your wind. So we are going to say that the wind speed is the positive 35. As we solve for X. And again, I like to use W for wind. I would have done this a little different and said W for wind. Does that sound okay? All right, let's do the next example together. You are riding your bike to a store. Your mom sends you to a store and the store is 4 miles away to pick some things up for dinner. If in a perfect world there's no wind, you're riding your bike at 10 miles per hour. But we're saying that there is wind. We're saying that to the store, we're assuming, here's your house.
It's a great house.
Like my house. There's your house.
That's a
coming out of
chimney. That's a chimney.
Why is it always happening?
So it is architect.
Where are we going?
Same.
Going to Kroger. Like my picture?
That looks just like Kroger.
Doesn't it?
Just like Kroger.
We're picking up
To scale.
we're picking up a chicken.
Chicken.
This is me.
Based on
And you're
chickens.
riding your bike.
Live chickens.
Do I need to draw a bike?
Yes.
Yeah. Bikes are actually hard to draw when you think about it. Is that to scale
Big
because
look at
your bike is
Mercedes.
as big as
Yeah,
your
that's
Oh, baby.
Is that it? Do you drive a Mercedes?
Yes.
Or the gears on the bike.
No pedals.
Yeah, not just a board with 2 wheels
It's
on it,
good.
it's a car.
That's pretty good.
Legs, you need legs.
So you have no pedals. That's all you're getting.
Does she have pegs? Is her brother riding with her?
All right, next.
So now, from your house to the store, it's 4 miles away. And we're pretending like we're going faster there. So to the store, it's 4 miles, and there's wind, tailwind on the way there.
Cool with that.
So it's 10 plus W. You're riding at 10 miles an hour, and the wind is making you go faster. How fast? We don't know. We're gonna figure out what the wind is in a minute. Going back home, you're going against the wind. So
you cancel
it's
everything
still
out.
4 miles, but it's 10 minus W, the wind speed. How did I tell you how to find the time? Well, if distance is equal to rate times time, time is distance over rate. So what would the time going to the store be? It would be 4 over 10 plus W. In the way back home, it's 4 distance over 10 minus W. So this is the entire time it took us to go from our house to the store back home. Okay, how long did it take according to the problem? How long did it take?
1 hour.
How long?
1 hour.
1 hour. So we're gonna take this and this, and we're gonna add them together. So the time 1 is 4 over 10 plus W, plus the time going back home is 10 minus W, is 1 hour. There's your story problem. How do you solve this now?
10 plus W, 10 minus W is equal to
What are we multiplying everything by?
10 times W, 10 minus W.
Okay, what do I do next? Sorry, it's kind of all over the place, but tell me what to do, direct me. What do we do? Cancel. So what do you have here? 40 minus 4W plus, what happens here? What do you have? 40 plus 4W
I have the same.
equals, what's this?
10 W, 10 plus W,
100 minus W squared.
10 minus.
Okay, what cancels out here?
10 times.
These two? What's 40 plus 40?
80.
Now, these ones where it's missing a middle term, I would take the square root of both sides. I'm gonna subtract 100. Negative 20 equals negative W squared, then what? Divide by what? Negative 1. What else?
Square and square root.
Square root. Now, you could say plus or minus 2 root 5. But when we're talking, I want to know the speed of the wind, I would convert this to a decimal. Square root of 20 is 4.5. It's approximately 4.5. So how fast was the wind? About
4.5.
4.5 miles per hour. What did we do with our negative answer?
It's extraneous.
Discard it. You can't have negative wind. Okay? Next. I like these problems. These are really easy. So you have two people, Carpenter A and Carpenter B. One person works faster than the other. Carpenter A can build a deck in 6 hours. Carpenter B can build that same deck in 8 hours. He's a little slower. If I decide I want this job done faster, what am I going to do? I'm going to hire them both. How long is it going to take them to do my deck? Well, Carpenter A can do, what portion of the job in 1 hour, working alone. If it takes him 6 hours,
You do half of it,
each hour, he can do a sixth of the job till it's done. So hour 1 is 1/6, hour 2 is 2/6, hour 3 is 3/6, 4/6, 5/6, 6/6. Okay? Carpenter B can do the job in 8 hours, so in 1 hour time, he can do 1/8 of the job.
4 6.
So what you're gonna do is add these up and set it equal to 1. So in 1 hour time, this one's doing 1/6, one's doing 1/8. So 1/6 x plus 1/8 x is equal to 1. How do you solve this now, off to the side?
24.
24, what's 24? 24,
5 or 2.
and I write 25. So, I already taught you how to solve it. This is just the application stuff now. What are you gonna do now? Six goes into 24 how many times? So you get 4x. 8 goes into 24 how many times? 3 times 1x is 3x. And 24 times 1 is 24. Next, what do you do? 7x is 24. You're gonna convert 24 sevenths, I would convert it to a decimal. It's about 3.4 hours. So approximately, we use a squiggly equal to sign. 3.4 hours if I hired both of these guys. Now, I want you to think about this for a second. Does this sound right? Does it make sense?
Yes.
If one guy can complete the job in 6 hours and another guy can complete it in 8 hours,
It should just take 7 for them to do one, because if you think, that guy can do half of it in 3 hours, the other guy can do half of it in 4 hours. So you think if you just half it and you put it together in 7 hours, it'd be done.
no, it's only 3.4 hours.
I know, but do you understand what we're saying though? Yeah. You're not really.
Like,
They're going at the
he
same
means
time.
like taking the 6
They're not
hours
fucking
for A
looking at
and
this.
splitting it in 3, because that's half of his job, and then taking.
They're working
the
at the same time.
Yeah,
So
they're not
one's doing it in
working
4 hours, the
Yeah.
other one's doing it at the same time in 3 hours.
Yeah.
So that's 2.5.
maybe they should specify that in the problem.
What?
What if they don't work together?
You should,
Yeah, what if they like hate each
What if
other?
anything, you guys?
What if they hate each other?
It says, how long will it take the carpenters working together to build one,
What if they
Oh, no.
right?
I don't know, Nick, what you're saying, Nick, it's 7 hours.
Because you cut it in half and then added them.
Right,
That's
so that guy
what-
can build a
that's
deck in 6 hours, right? So he can build half a deck in 3 hours.
Because there's 2 people,
Half
so
that
you
time.
cut that in half
So if he
and
builds
then
half
add.
a deck in 3 hours,
It's wrong,
the other guy
but
can-
that's what we did.
Right.
It's wrong.
it's not, we're actually really stupid,
The
but
reason behind
it
it.
makes sense.
But we can back
Okay, let's do the next one and see if you guys can guess what the answer is. Doing it your way.
No.
Well, that way didn't work out that
I
way.
know. Okay, we have 2 delivery guys. One driver, working by himself, can deliver a complete route in 6 hours. Another driver is doing it in 5 hours. So if they did it together, is it gonna be 6 hours? Is it gonna be 5 hours? No, 5.5.
If they're gonna do it together,
Is it
like
like
that.
2.7?
Yeah, that doesn't make sense.
A carpenter thing is different, but this one, if you're driving,
They're not
what are they
driving.
gonna,
Then it'll just.
They're
I
not-
just remember driving is really.
No, they have two separate cars.
Let's
But they're
do
working
that.
it
How they're working it the same route,
It's
but the
alright,
same
guys, it's
map.
just a story problem.
They don't even apply in real life.
You guys are
Go
really
here.
reading into
This is fantasy world.
No, they're
Why is there
same
an
route,
X?
why is it
Just
one
take
different X?
Huh?
Why is it, where's that X supposed to be, on top, on the bottom, or
It's,
you
you
multiply?
could do it on top or in the middle. You could write,
So
you
it's
could write
one
this.
times-
Where are you getting the X?
It's your own home.
This person is doing 1/6 of the job,
So it's
each
1/6
hour.
times X.
1/6 times X, that's what that says, 1/6 X.
Whoa.
Nick, driver B, what portion of the job does he do in 1 hour working alone?
1/5 X.
1/5 X. Now, we wanna do this job together, so you're gonna do 1/6 X plus 1/5 X equals 1. Each hour, they do 1/6 or 1/5 of the job.
30.
So what's your common denominator?
30.
So we're gonna multiply this by 30, this by 30, and this by 30. Tell me what I get right here. 5x plus 6x equals 30. Okay, next,
11x equals 30.
next,
X equals 2.7.
and that's about 2.73 hours. So, about 2 hours and 45 minutes, almost, a little less than 45 minutes, but 2.73 hours. The job will get done if they do it together. This is assuming that they each have a car and they're not doing the same route. You guys are like thinking too much into the problem, okay? But if they did the same thing, working together,
Should be.
okay? So what do I want you to do?
4,
None of it.
20,
This back
37,
page.
33.
Homework? That's your homework. Brett?
Yep.